So in the previous video, we've shown that your power in the resistive load is given by Vi cos theta, and it is the real power which is always positive. So you find out that it will have a certain power difference. It's like either which is absorbing I, that is how we express power into the circuit, and no net power is dissipated, and that is the expression that you can use for inductive reactive power, and it is positive. And for the capacitor, you realize that it is negative, so it's a negative inductive reactive power. The next thing is the general load, where we are looking at a load with both current and voltage which are not in phase but have a phase difference, say theta, and that is the expression that we got, and that portion highlighted is always positive and is the one which is measured in watts. Then the other one goes positive and negative, and is a matter of exchanging power between the source and the load, and its reactive power measured in VA reactive. Then there's also power that seems to be apparently consumed by a system, and that is given by Vi, and it encompasses the whole load, so it's I squared Z, and that is apparent power measured in volt amperes. So we can say that the real power, or P, is called Vi cos theta, where Vi is called S, so it can be written as S cos theta, and then the reactive power is Vi sin theta, which is given as S sin theta. And then because of that, you can also determine the power factor. In this case, it becomes real power over apparent power, and that gives the portion of the apparent power that is dissipated in the system. And so if you look at those expressions, then you realize that for a certain load, then S squared is called P squared plus Q squared. We will look at it when you look at the power triangle. So that is the general impression of our power, where the real power or the real work is being done by this part of the power. This is the reactive power, which is just circulating, and we can say it's actually wasted electricity. But then what seems to be the whole power consumed by the load is the full length of that component. That we can draw our power triangle, where we have the real power and the reactive power, and then this becomes our apparent power. So in such a situation, Q is positive if the inductive reactive power is greater than the capacitive reactive power, and Q is negative if the capacitive reactive power is greater than the inductive reactive power. So for these two reactive powers, you just subtract one from the other, and taking note of the fact that the capacitive reactive power is the one which carries the negative sign. So in general, we can say that the total real power and the total reactive power will be combined to give the total apparent power. And so S is called the square root of Pt squared plus Qt squared, and the power factor is the real power over the apparent power for a given